I'm James Sillett and I'd like to thank you for taking the time to watch this video. If you have any comments or questions, you can contact me by any of the means shown below. Now all add-ins have to be registered within Vcenter. So that's what this page does. It takes us to our Vcenter registration, and all we have to do here is put in the host name of the server that's running the add-in, which as we've installed it on the same server as the Vcenter, is the same IP address as the Vcenter, and just to pop the password in. And this lets us know that the registration was successful. And that's all that's needed to install the Vcenter console. Okay, so now we've finished installing the virtual storage console, we open up our Vcenter. So now we're logged into our Vcenter desktop client. We can see under Solutions and Applications that there's now a Netapp icon. If we click it, we're going to get an issue with our certificate. Now, if we've got a PKI infrastructure, we can follow standard documentation and import that into Vcenter, so that we don't get the certificate warnings. However, even if we do that, if we're using Vcenter on a computer that's not in the domain and doesn't have the trusted root certificate, then we're going to be prompted with this kind of warning message. Now, normally we feel we can just ignore these. Unfortunately, if we do that, some of the pages are not going to show properly. So we do need to import this certificate on our individual machines into the appropriate store. So we view the certificate, we're going to install the certificate. If you have the permissions, it's better to do it for the machine. And that is the root, the trusted root authority certificates. Okay, all done. So if we now come out of Vcenter and go back in, you'll see we are not prompted for the certificate. Okay, so what we need to do first of all is set up our connection to our controllers. So it's picked up one controller, but we need to add our other controllers. So let's modify the credentials. Okay. So we've got both our SANs here, and we can see it gives a very quick overview of the storage, capacity, and the protocols that we're currently using. Now beneath this will list all our ESXi hosts, and initially when it's installed you'll get almost definitely some red X's in these locations, and that's because the best practice have not been applied. Now, we can resolve this by right clicking and selecting set recommended values. This will give us our 3 ticks effectively, and we'll then need to reboot each ESXi host, and then the optimal settings will have been set for each ESXi host for communicating with the Netapp. Now, what we also have is the tools needed to set the correct timeout settings for Iscsi on each of our guest operating systems. Okay, so we have the 2 different timeout settings. We've got the 60 and the 90. Now, the 90 seconds were historical, and the settings that were used in previous versions of Netapp. Now, the newer settings are recommended to be 60-second timeout settings, but we would advise that you read or Google around this to work out what's the best ones that you may need. So what we can do then is go to the URL as shown here, and this will give us the ISO file that we can mount and run against each of our individual guest operating systems. It is time consuming, but most noticeably it is worth doing, because in the event of a failure, or even when you're putting one of the SANs into maintenance to update the firmware, which we'll be doing later, then you will get unexpected performance from your hosts, from your guests even, if you don't run these scripts. So if we want to use this, we go and find the URL, copy to clipboard, open up a browser, copy it into the browser, and then we can save this file. Okay. We need to then copy this up to a place where we can mount it. So let's go to our storages, copy up, upload a file, okay, take our CD-ROM drive, find our settings. Okay. All this is going to do is add some entries to our registry. Okay, let's add to the registry, and then we need to reboot that guest operating system for them to take effect. Right, so let's return to our Netapp add-in. Once we've got these 3 symbols here as all good, what we should be able to do is have a look at our data stores that are on the Netapp. So in the past there was issues with having a lot of guest operating systems accessing one lung on the SAN. This was due to Iscsi reservations that would cause the locking on that particular lung. Now, using the built-in APIs and storage SDKs for VMware, vendors such as Netapp have now got around that by using a different kind of locking mechanism. And we can see that that is working when we see supported there. If we look at our local storage, we'll see not supported. So what we can also do now directly from within Vcenter is create a new data store. Provisioning and cloning, and provision a data store. Now this is the area where if you don't have the certificate set up correctly, this will just hang. We can select either of our SANs. Now we've only configured Iscsi, so we can only use VMFS. And we can create the size, so we can create 150 gig. and we're going to create this as a and we're going to create a new volume. And most importantly, we're going to use thin provisioning. Apologies here, you need to, can't actually spell. Okay. So that's going to go away and create the data store on the Netapp. And we can see that the new data store has now been created. And we look in configuration, we can see that it's supported and it's automatically associated it and done all the relevant path information. You see it's set up with the round robin. More importantly, if we need to extend one of these in the future, we can go and resize. So we can set this up to 200. Okay, and now we can see we have 200 gig free. We actually look at the properties of here, we can see what the block size is. So the maximum file size here is 2 terabytes. Okay, we can look at this back on the Netapp itself. If we go and have a look on the SAN2 and the volume, we can see let's look at the lung first. We can see we created a lung of 200 gig. And if we look at this, we can see that this is thin provisioned 200 gig. If we go and look at the volume, we'll see that the volume is only 150 gig, our original the original size that we set up, and it wasn't expanded. But we can see that it's thin provisioned. But more importantly, if we edit this, we can see that it's allowed to auto grow. Now it's allowed to auto grow to a maximum of 310 gig with incremental sizes. This means as the lung gets filled to over the 150 gig that's been allocated at the volume level, the volume will automatically grow. We can of course increase the storage from the Netapp side. So if we go to the lung and edit, we can increase this to 400. Okay. If we return to Vcenter and go to properties and increase, we'll see now we have the option of increasing the data store due to the fact we've increased the lung. And we can use the maximum additional 200 gig. So we've taken all this space up, but actually if we go back and look at our aggregate, look at our volume layout, we can see that actually we've only utilised 30 meg of that overall space. What is deduping? Well, deduping is a process what the Netapp will do within a flex volume to look at recurring types of data that are similar. If it finds parts of data that's similar, what it will do, instead of holding that data twice, it will use markers and store the physical data once and then place a marker for any other times that data is used elsewhere. And this can significantly remove the amount of underlying storage that's needed. Now typically the most common use of deduping starts at the operating system drive, the drive where you've installed your Windows OS. The reason for this is that if you think you've deployed 20 or 30 Windows 2008 R2s, there's a significant number of files that are going to be identical, including the service packs, the Windows 32 directory, and all the key areas of the operating system. Now if you've deployed this 20 or 30 odd times, using dedupe can save a significant amount of space. For this to work properly, you'll need to make sure that you've put your operating systems within the same flex volume. And that's why during our design phase document, you'll see that we created a data store for actually storing our operating systems in. Now I've got 4 VM Windows 2007. And what we're going to do is we're going to create a data store from scratch, and we're going to storage motion them in there, and then we're going to run dedupe and see how much space we save. So we're going to start off by creating a new data store. Okay, so all those data stores have moved across, and if we look in our Netapp tab, we can see at the SAN level, select the dedupe volume, we see 14% of the data store has been used. That's 13% of the lung, 30% of the volume, and obviously 6% of the data store. What we're now going to do is go to our dedupe settings. Okay, and we can see that we've used 27 gig. So what we can do is we're actually going to start the dedupe now, and we're going to do a full scan. Okay, now this you do need to realise this puts a load on the Netapp. It's going to take CPU performance. So normally we will schedule dedupes out of hours. Now that's going to take a while, so we'll come back when that is finished. I'm James Sillett, and I'd like to thank you for taking the time to watch this video. If you have any comments or questions, you can contact me by any of the means shown below.